Now look at this.
What's up, baby biopenguins? Today we do topic 4.2 on introduction to signal transduction. There's 3 steps to signal transduction. First step, reception. This is when the signal, the ligand, is going to bind to the receptor and it causes it to change shape. Receptors are proteins, and if you bind something to a protein, it always changes shape. Second step, transduction. Transduction is when we're going to transduce, bring the message into the cell. This does not mean that the actual signal, the ligand travels. This is just the message. So it's the kind of almost like a domino effect. And then the third step is response. Response would be like, I don't know, gene expression or secretion of a molecule or, of course, cell growth. So this is a G protein coupled receptor. So what that means is that it has a G protein on the membrane. It's going to bind to the ligand, which then causes a GTP to bind to it. When the GTP binds to it, that causes the G protein to be active, which then continues on the whole pathway. This is a ligand-gated ion channel. What that means is that the ligand is got to bind to the ion channel, and that causes it to change shape, which then is going to cause it to open. So now the ions can flow down their concentration gradient. So like chlorine will come in, or sodium will come in, or potassium will come in, whichever the specific type of molecule that we're looking at in that example. Our last example is a receptor tyrosine kinase. So you see in the very first picture, we're going to see that the ligand, the signaling molecule, is going to bind to the receptor. That activates it. And so when it gets activated, there's 2 of these molecules and they come together. So they form a dimer. And you see in our third picture, we're now phosphorylating. That's where the kinase component of this receptor comes into play. So the kinase means it's going to add phosphate molecules. It's phosphorylation. So we're going to phosphorylate each of the tyrosines that's part of that receptor. And that's going to lead us into some type of transduction. G protein coupled receptors oftentimes work with an adenylate cyclase. Adenylate cyclase is going to convert ATP into cyclic AMP. That cyclic AMP is then going to act as a secondary messenger, and it's going to activate protein kinase A. As I said before, kinase is going to phosphorylate. So this leads us into a phosphorylation cascade, which is part of transduction. It's going to phosphorylate different relay molecules to then, every time that they get phosphorylated, they're programmed to do work, which then activates all those relay molecules. So another form of transduction we have is where we have the secondary messenger of calcium. Calcium is then going to activate a protein kinase, and then again, our phosphorylation cascade will take place. So there's a lot of different responses that can happen in the cell. The 3 that are directly out of the CED is cell growth, secretion of molecules, and gene expression. So turning on or turning off a gene. So this is an example of what was on the 2022 AP exam. So you're not going to have to actually know all the pathway and what's happening in it, but you're going to have to be able to apply to some type of example pathway that they give you. So I hope this was helpful. Hit that follow button because I'm doing this for every single unit. And remember, AP Biopen's just success. Bye, y'all.